Good morning, everyone. Oh, I've got to flip my camera slider. There it is. I was like, why isn't my camera on? Good morning, everyone. Or good morning for us over here on the West Coast. Good day to everyone. How are you? Thank you so much for coming back and joining us. Thank you, Michael and Oleg, for returning. It'd be a lot more of an interesting show if you hadn't. So, how are you feeling this morning, Michael?
Good. And well, in that case, we're going to leave you to this and see how this
Right?
goes.
Here we go. Bye. No, it's really nice to have you all join us back. Hopefully, you have some good questions because we'll have some good answers for you. We do have some of those questions prepared from yesterday already to fire away. Yvonne is ready with those, and then if you have any more, please feel free to hit the Q and A button and submit your question. And then if we have some time at the end, Oleg's going to do some demo for us, which is great. So nice to have both of you here, both your brains to wrap around these questions, as well as Oleg to show some more stuff. So this will be a really fun hour, and there will be no breaks. It'll just be boom, lots of great information. And I don't think I need to say anything else right now because I just want to get to you all. One more thing. If you missed yesterday for whatever reason, or you were able to only join for a little bit, a reminder, all of that will be posted online that you can watch later. We'll send you the links, all that in a follow-up email. And then also, I think that, Michael, you have that GitHub repo URL that you want to share with everyone too. So those are, I think that's my stuff for now, and I'll see you all in a little bit. Away you go.
All right. Really quick before we get in with Ivan and questions, like Bob mentioned, I did post all the code and the deck from yesterday on GitHub, and so that is at github.com/mminella MMINELLA /SCDF-ecosystem. You'll be able to find all the code and whatnot, the deck, etc., available there.
And we can make sure that email address, if they didn't have their pen and paper handy,
yep.
We can make sure that's in the email that gets sent with the follow-up and everything like that too. So thank you so much for putting that up. I know everybody's going to be excited to review.
And with awesome.
That, so we have a couple of questions left over from yesterday. The first question is really about getting Spring Cloud data flow into production and what that looks like, what are the best practices, and what that means for disaster recovery and high availability.
Sure. So with DR and high availability, you typically are talking about, multiple data centers, multiple instances of applications and those kinds of things. And Dataflow can manage most of that for you. So you can have one instance of Dataflow pointing to multiple foundations or platforms as we consider it on Dataflow. So you'd configure, let's say you'd have a primary and a secondary data center, and you can have each one of those configured independently. And so when you go to deploy your applications, you can actually say, deploy this to platform A or deploy this to platform B or those kinds of things. You can also configure the number of instances and those kinds of things available within Spring Cloud Dataflow. So it has all those capabilities. It's really about how you want to architect your situation. You can also go completely independent. You can have a data flow for each instance for each. That's another common way we see things. But in general, yeah, all the capabilities are there. It's just a matter of how you want to configure it based on whatever your standards are for your company.
I guess the only other thing that I would like to add is that because Dataflow is based on connecting the apps via, I guess, for the lack of the better term, production-grade messaging systems such as Kafka, Rabbit, and so on and so forth, those themselves provide that level of capability with regards to cluster security and everything else. So I don't want to get too deep on that, but
that does bring up
an element of
No, I was going to say that does bring up the fact that Dataflow probably the easier thing to manage in the apps. Really,
Yeah.
the hard part is the data stores. So the
Right.
databases, the queues, all that kind of stuff. That's the more complex stuff, in my opinion.
Right.
And that's something that obviously Dataflow itself doesn't handle. Kafka has its own facilities for doing that. Rabbit has its own. MySQL. Each one of them have their own to manage that kind of thing. But
And also, as you said yesterday, in theory, you can just shut down Dataflow once Dataflow is running, because Dataflow server doesn't really need to be there.
correct.
So the next question we had left over are there any plans to provide like standard apps with the community stream binders?
So we're currently in the process of refactoring most of the out-of-the-box applications to be function based, using the coding that I used yesterday, where you implement supplier function consumer. And with that, they're also being refactored to be a starter for each one. So the idea being that you would be able to build your own application doing this. So you'd bring down the starter for the appropriate thing, add in whatever binder you need, and then build the application yourself. We don't have any plans, to my knowledge, of creating basically the the Cartesian product of all the apps times all of the different binders, including the community ones. We don't have any plans of doing that currently. It should be a pretty straightforward exercise to do yourself, though.
Thanks, Michael, for clearing that up for us. Is it also, this is kind of a weird question, so is it possible to configure Spring Dataflow declaratively?
Not sure what that actually means, so maybe a follow-up or some kind of a clarification, Michael.
Yeah, if the person that asked that question is on today, if you could clarify specifically what you mean by declarative in the QA, we would love to. More than happy to answer. Just not 100% sure what you mean by it. Yeah, I mean the way I configured it yesterday was all via just YAML declaring stuff, so it's not. I'm not 100% sure what is it the server, is it the applications, yeah, lots of questions.
Because
so if you
the
clarify.
the Spring language is imperative, right? But the way you were using it was declarative with Kubernetes, right?
Exactly. Yeah. So so the Dataflow server is declaratively configured because it's all YAML, just like Kubernetes is. From a, I mean, yeah.
And would it be possible to configure another registry to pull from instead of Docker Hub?
Yep. Yeah. So you can configure, and this goes both for Docker or Maven. So if you're using Cloud Foundry, you're probably using Maven and UberJars. If you're using Kubernetes, you're obviously using Docker. You can configure whatever repositories you need and as many as you need. So you can configure more than one, and Dataflow will pull from the appropriate one. And you can configure authentication and all that kind of stuff as well. So all the usual enterprise stuff you need to utilize your in-house repositories is available for you with Dataflow.
Thanks, Michael. That was the last question that we had left over.
Cool.
Thank you so much.
All right.
And I'll keep monitoring the chat and helping out with the questions. And I believe Oleg has something he wants to show us today.
Sure, I can.
Yep, it's all you, Oleg.
Tell me when to stop. So I guess I'll hold on. Let me disconnect some of the communication facilities. So
while you're doing that, do you want to kind of tee up what you're going to be talking about?
Michael, you know I can't multitask. I need to just close. All right, now so basically, Michael had a kind of started a very good discussion on not just the data flow, but kind of like the end, like why are we what's the use case? What problem are we trying to solve? What I wanted to do is kind of go backwards and say, okay, well, you know, in the concept of means to an end, what are the means, right? So what those applications kind of look like, right? So for example, well, Michael showed you the functions yesterday, and I'm going to show you again today. But why this functional model is so important, and this is why I want to talk to you about, because when I sort of took over this project, even at the time I didn't realize it, but once I started working on it, it kind of became very clear to me, and I sort of become kind of like infected by this notion that if we had Java functions since Java 1, a lot of our APIs, a lot of our products, a lot of our frameworks would have been so much simpler. But fortunately, we got it at Java 1.8, Java 8, whatever you want to call it. And at least right now, we can look at the Java ecosystem in a sort of a better way. So now I'm ready to share the screen, and let's see. So I'm actually going to show you a little slide deck. Come on. Wow. So Michael was telling you a story about his bad boss. Actually, his boss is really good. But I'm going to share you the story of two ice creams. Well, this is actually the same ice cream, right? So, and same strawberry ice cream, except in the picture on the left, that's just the raw material. The picture on the right, decorated, you know, plated, properly served, probably cost more money, and so on and so forth, right? So you can look at, so this is a good analogy when it comes to understanding why functions are important, because function is a raw material. So look at this slide, and basically you have a functional bean that in this case does the uppercasing, and this is it. This is your functional requirement. So when you read the use case, when the use case was delivered to you, you extract functional requirements from it. So the other non-functional just has to get away and addressed at some point in the future, or at some point, basically addressed not by you, but by something else. And this is where the frameworks the ones within Spring come handy. So for example, this function represents the functional requirements to uppercase a string. But how do you invoke this function? You can invoke it, for example, you want this function to become a REST endpoint and invoke this over HTTP. So how much legwork do you really have to do? And I'll show you, not a whole lot, or not at all. Or for example, like I was mentioning yesterday, the new exciting thing that I'm going to show to you in a few minutes, RSocket, right? So you can invoke these functions over request reply method or any other method available for RSocket, right? So, or what if you want to deploy this function on one of the serverless platforms? So as you can see, the whole point of the slide deck is the function in the middle doesn't really change. It remains the same. What changes is the world around it. And what Michael was showing you yesterday is a function that sits somewhere in between the binders. Could be the same messaging system, could be a different messaging system. Again, function doesn't change, but what's most important, function doesn't even know who is invoking it. It just that something will invoke the function. And this is the contract between Spring Cloud Function and the framework that uses Spring Cloud Function. So for example, in this case, we're using Spring Cloud Stream. So Spring Cloud Stream will know how to interact both with the broker API as well as with Spring Cloud Function. In the previous slide, we provide a capability for Spring Cloud Function to understand how to interact with, how to live in the world of AWS or Azure or Google and so on and so forth. And the same with RSocket. So it kind of goes it's very bi-directional. So, so Spring Cloud Function, it's a framework which promotes implementation of business logic via Java functions. And when I say Java functions, I implicitly mean supplier, function, and consumer. So, which is, as Michael explained yesterday, supplier, it's basically producer of data, source of data. Function is both producer and consumer, or consumer and producer, if you left to right. And consumer is obviously consumer. So the features, and this is just a very small subset, transparent type conversion, which I'll show you in a few minutes. function composition, which I will show you in a few minutes. Closure functions, I'll talk about this. There is really not much to show because if something looks like a function, smells like a function, we'll treat it as a function. So if it's a functional interface, meaning that if it fits into the functional model, we'll have no problem dealing with that. Reactive support, which I'll show you today. Deployment of package functions, which again, I can talk to you about. It's a little bit irrelevant to this talk, but ability to package functions as jars and then deploy them. Already, again, not going to show it today, but just something that you should be familiar with, that we can write functions that supports multiple inputs, multiple outputs for streaming use cases. For example, very relevant use cases for that is like a typical big data use case where you collected the data undiscriminatively, and now you want to sort it out. So you pull it from a single input, but you want to sort it out to 2, 3, 4, 5 different outputs, right? Or the opposite of that, you want to be able to merge the data or aggregate the data and so on and so forth. So, and as I already mentioned, integration with serverless platforms and a variety of different Spring frameworks. So I'm going to start right here and actually quickly check if there are any, well, if there are any questions, but I think I see that there's only one question. But anyway, okay, so I'll move on. So I hope, go ahead.
So, sorry, Oleg, there is a clarification to that question on using data flow declaratively.
Yeah, should we?
He was just asking if you could set it up through YAML rather than using the GUI.
Oh, set up stream definitions or stream definitions
set up the whole Spring Cloud data flow.
So data flow itself, there's no GUI to configure. That's using YAML. You'll see that in my code repository. Defining the streams, though, you can do it declaratively, but not via YAML. There's a text-based DSL that we use that you can use. So if you were to go back to when I was dragging and dropping on the UI, I think I showed it at the top. There's a text box that's updating. You can do it all via the text and an interactive shell and do it that way if you want. And not have any, and not get involved in the GUI at all, if that's the way you want. I use the GUI because it's just better for video.
That makes sense. Yeah, I think he was probably wondering like how to set up a pipeline rather than using the GUI. So it looks like we have another question from George. He's saying, hi, so far I've been developing batch apps using Spring Batch and Quartz for cluster scheduling with multiple JVMs. What's the next step for me? Multi-JVM partitioning or move straight into what was presented yesterday? The batches are ETL operations with some REST API enrichment. Thank you.
So it really depends on what you need. So they're kind of orthogonal issues. So one is about where you're going to run an orchestration. One is about scaling, right? So if your current pain point is how do I launch my jobs? How do I manage those schedules and those kinds of things? And moving to what I showed yesterday with Kubernetes and Spring Cloud Dataflow makes sense. If your current pain points are performance and you're trying to get more throughput with regards to the through your jobs, then you'd start exploring partitioning and the other scalability mechanisms that Spring Batch provides. So it really depends on what's your current pain point. And to be transparent, you'll probably, in long term, you'd probably end up using both. If you have a robust batch infrastructure, you're probably going to use partitioning on some batch jobs, and orchestrating them via data flow makes sense, in my opinion, in general. If you got more than a couple batch jobs, I would explore data flow to orchestrate them anyways.
Thank you.
All right. So you can see my screen, I'm assuming, and those of you who are live, tell me if you're not. So as you can see right now, you're looking at the simplest possible Spring Boot application. just as simple as what Michael was showing you yesterday. Nothing different. So we have a function string, uppercase. We're just going to simply uppercase the string as you've seen just on slides, right? There's nothing else. There's no hidden property. Here's application properties file. As you can see, it's absolutely empty. And the only other relevant file that we should look at is, of course, POM file. Again, as Michael was showing yesterday, that's we kind of like, in Spring, we went from XML to annotation and kind of back to XML via POM. So this is where we kind of now are managing our application. So again, right now my code doesn't compile because it doesn't see anything because I commented everything out. So right now I'm going to look at this function, and let's say I want this function to become a REST endpoint. How difficult would it be to achieve? Well, it would be as difficult as just adding these two dependencies to your application. And at this point of time, everything compiles, and all I need to do is just start the application. And localhost uppercase hello world. And we got ourselves uppercase hello world. So uppercase became the name of the function, and hello world became the payload that I'm sending. So again, could be get, could be post, depending on the style of the function. So we support suppliers, functions, consumer, and so on. So again, some of the details available in documentation. I mean, most of the details are available in documentation. But the point here is that this is actually a very important point, is that what we try to do within Spring projects that are under Spring Boot or within Spring Boot ecosystem is that the simplest way for somebody to get started, which is, as you can see, I did not have to configure anything. I did not have to do anything extra other than just add dependency. Sure, for some, when you start addressing certain complexity where you need to say, I want this functions, not that functions. Yes, there's certain configuration elements that you can provide, and I'll show some of that in a few minutes. But the reality is that for something from how you get from 0 to 60, it should take you literally no time at all. And it's, like I said, it's really that simple. So now, just kind of following the slides, I want this function to become, let's just make it a, what do we have next? Stream. So let's make it a stream. So I'm going to use Rabbit binder. So actually, bookmarks, Spring Rabbit console. Okay, let me just delete this stuff so you can see the full what's going to happen. Delete. Okay, so I deleted the stuff that was there. There's no queues, there's no exchanges. So now I'm going to, again, start the app. As you can see, I didn't do anything extra. I'm going to start the app, and the app is running, right? So now all of a sudden, sorry, wrong browser. So you can see there's uppercase in, uppercase out. So again, if for those of you who may have used Spring Cloud Stream before with the old annotation-based model, you had to define bindings, define a binding name through enable binding annotations. So in other words, your application became heavily sort of dependent into Spring Cloud Stream abstractions. Now we are basically using conventional configuration. So remember, Michael had these two properties where he had to map his processor in 0, processor out 0 to input and output. That's because data flow expects for message handlers to be exposed under those names. But in my case, I don't really need to, because I can communicate with an endpoint with the binding name directly, which corresponds in this particular case to exchange name. So now I'm going to say hello world. And as you can see now, the function was invoked, and just like that, something that 2 seconds ago was REST endpoint also became actually became a message handler. Well, guess what? It is still a REST endpoint because I forgot to comment this code. So, and here we go. So now all of a sudden the same function works together as a REST endpoint and also as a message listening container. And finally, well, there's a few questions, if I may, to peek at them. Not related.
Yes, Oleg, there's one question regarding multi-JVM scaling is supported in SCDF. Can you please elaborate why Spring Cloud Dataflow isn't better than Spring Batch?
Why Spring Cloud Dataflow isn't better than Spring Batch? First of all, I'll delegate it to Michael, and I don't think it could be even... Okay, Michael.
Yeah, sorry. Can you just repeat the question?
Yeah, I think they're really wanting why should you use Spring Cloud Dataflow? Why isn't it better than Spring Batch?
So Spring Cloud Dataflow orchestrates. It doesn't do the actual work. So comparing the two, comparing Spring Cloud Dataflow and Spring Batches, it's not a apples to apples comparison. Spring Cloud Dataflow launches Spring Batch applications via Spring Cloud Task. The conversation may be Spring Cloud Stream versus Spring Batch, and then it really depends on your workload. Are you receiving messages? Are you receiving batches of data? Those two fundamentally different workloads. So you'd use the appropriate framework for the appropriate use case. But Spring Batch itself can do multi-JVM scaling. It can do partitioning. It can do all the things that you'd expect to be able to build a scalable, robust batch application. Dataflow does none of that. Dataflow launches other applications to do the work. So yeah, I don't think it's the comparison isn't quite right.
Yeah.
Thank you, Michael. The next question is when the Spring function is deployed to a cloud provider, for example, AWS Lambda, is the embedded server needed anymore?
No, and I already kind of saw this question. So just to give you opening up AWS example, you can see the only thing that is required is adapter AWS. And we actually did quite a rework on that. So there's right now, you don't even need to implement anything. There's, as you can see from the example, you still have this one uppercase function. If you remember for those before, you had to implement the request handler. You can still do it. It is still supported, but there's no longer a need for that because we provide a universal request handler that will handle, Kinesis API gateway, streaming, everything. So basically, it's a function invoker, and it's documented. If you look at the AWS documentation for in Spring Cloud function, there's a whole quick start that takes you step by step with the screenshots and everything. So, all right, I'm gonna move on quickly. So we had stream. Okay, and now our socket, right? So, and then I'll see there's more questions, and I will answer them, of course, as well. So, okay, so our socket actually just to so if I wanted to do our socket, obviously I need to let me just remove all this stuff temporarily, or and I'll re-enable, we'll enable RSocket. So right now, basically we have Spring Cloud function with RSocket support, okay? So at this point of time, all we need to do is literally just, so the function is going to be, shouldn't use the word deploy because it's not really being deployed. Just the function exists out there as part of the application. And what we're doing with our socket support or streaming support or REST supports is exposing this function, decorating, plating it, serving it to you as either REST endpoint or RSocket endpoint or streaming endpoint. So in this case, what I'm going to do is literally just grab this. So just for testing purposes, I'm going to grab this piece of code. And all it is just a client code, so I can connect and invoke and so on and so forth. Again, there are a certain set of defaults. For example, by default, my function is going to be deployed in running in a local host, and port is I've chosen for now, 55s. But again, obviously that's everything is configurable. So And now we got to solve RSocket, right? And now if you're familiar with RSocket, RSocket gives you this capability of bidirectional communication over socket. So, and it exposes 5 different, or I think 5, maybe more, different methods to interact with, or several different methods to interact with. So in this case, what I'm going to show you is that the function is still the same, uppercase, right? But you can see also RSocket gives you this reactive support right out of the box. So, but what's interesting here is that while you making a reactive call to RSocket, the function is still imperative. So that doesn't stop one from being one being. In other words, it doesn't create any kind of incompatibility. This is where the frameworks negotiate how to deal with functions that may not fit the invocation model that the actual function was designed for, right? So again, I'm going to I'm going to run it, and we can see that function was invoked and we uppercase hello. What's interesting is that now we can again change the methods, change the way we're invoking this function. So in this case, I was literally depending on a mono because I'm sort of like, it's a request reply, request response. So I'm sending like even though it's a reactive API, it's kind of designed for sort of imperative world where send you a single request, got a single reply, single request, single reply. But what if I want to do a true streaming where I'm sending you a stream of requests and I'm receiving the response, which is also a stream that I can finally with your results, right? So again, I can do the same, even though function never really changed, function is still imperative, function still will process one single event at a time. I can still invoke it, and because I'm sending 2 events, so I'm going to get 2 outputs back. So, and again, Spring Cloud function will take care of negotiating this thing. So here we go, we got ourselves hello and blah. Now let's get to more interesting stuff. So far, you saw me like I have uppercase functions, so there should be questions around like how did framework recognize that there is a function and so on and so forth. Well, obviously, it's not difficult because if I have application context and there's a single bean of type function, you know, it's not difficult to we take approach saying if there's application context and there's a single bean of type function and you have Spring Cloud function in the class path, then you probably intend to use it, so we're going to use that function and so on and so forth. But what if we have more than one function, right? So now the code that I just, okay, let me uncomment this thing. Ignore the second function for now. So all that matters is that there's a second function, right? Let's not worry about what it does. So the only thing I just changed is added the function. So let me try to run this code again. And we got an exception. Failed to determine target function for RSocket. Why? Because now I have a conflict. I have 2 available functions. Which one exactly do you want? And this is what I was telling you earlier, that like to get started, single function, you need nothing. Now, when you have a little bit of a conflict, you're adding a little bit of complexity. Sure, you need to provide some type of a resolution mechanism. So all we need to do is provide a property, which is a single property that is used in Spring Cloud Function, Spring Cloud Stream, in variety of different ways. So we rely on a single property, which is Spring Cloud Function definition equals uppercase. Okay. So by definition, I'll explain in a second, because we used to contemplate it function.name or function.definition. We stopped the definition and it will become very, very clear in a moment. So let me run it again and everything should work fine, because now there's no issue. So now I'm going to change it to a separate function, reverse, and run it again, and things will of course break, but for different reasons. Oh, they didn't break. Actually, no, they. Well, that's interesting. Oh. Wow. Oh, yeah, I understand why. Yeah, the reason why, the reason why, let me just, the reason why I didn't break because, well, let me just try some. Let me try to break it, actually. I wanted it to break, but RSocket is a bad example to show because RSocket expects JSON, right? Just give me a second.
In the meantime, we have another quick question, whether the processor in Spring Cloud Dataflow runs in the JVM, in the Spring Cloud Dataflow JVM?
Good
No.
questions.
I would imagine so, right?
No, so none of the
Oh,
applications launched by Dataflow run in the same JVM. They are always run as external processes. So if you're running on Cloud Foundry, they'll run as separate AIs. If you run them on Kubernetes, they'll run as separate pods. If you run them in local, they'll still be run as separate JVMs. It's just your responsibility to manage that. So Dataflow runs nothing in the same process as Dataflow itself.
Oh, that's really cool. Thanks, Michael.
Right. All right. So the reason why I expected it to work, I'll explain later. Well, the reason why I expected it to fail is because I'm sending strings and the input to this function is actually not a string, it's a person, right? But as you can see, I'm sending a JSON string, and that's exactly what RSocket actually expects, right? So, and since we already provide, as we remember, I mentioned one of the features of Spring Cloud Function is transparent type conversion, which means we provide certain types of converters already assembled as part of the Spring Cloud function. And one of them is, of course, a JSON converter. So this created no problem, but I'll show you what I wanted to show you when I switch back to stream. So, but I can show you other stuff right now. So, for example, so right now we are able to invoke this function successfully because it has no problem. So this is actually a feature of transparent type conversion. We had no problem invoking this as a string. We also had no problem invoking this as a person because it had no problem creating um, um, from the string, which is a valid JSON payload. It had no problem creating a person because we provide a JSON-friendly structure to do that, and because we also have a JSON message converter that supports this type conversion, and application JSON is being a default type, right? But so that's one feature. Another feature I want to quickly show you is kind of goes into the heart of how we deal with complexity. A lot of times you look at the use case and it says, okay, I want to do A, B, C, and D. Well, okay, now it's your decision. How do you want to implement A, B, C, and D as a single function? Or you want to implement function A, B, C, and D, right? So the pros of implementing this single function, you kind of implement it, you package it as a single function. But imagine the testing of that function. I mean, how many different paths, how many different cases do you have to really test? And what is the cost of maintaining such function? Another approach is to implement A, B, C, and D, right? But you're rarely going to be using A, B, C, and D in isolation. You want to be able to somehow reassemble it back together. So you can create function F and say, listen, this is function going to be a wrapper over A, B, C, and D. Or you can do the same declaratively in uppercase. You can do the same declaratively within Spring Cloud function. So as you can see right here, this is why the importance of the word definition here, because what we're providing here is a definition which can correspond in simple cases to a function name, or it could correspond to a instruction of how to compose and so on and so forth. So sorry, I might need to. Okay. Oh, so now there's an exception happening somewhere in there, because it says uppercasing hello, because this is, so again, our socket feature is something that's work in progress. So and as always happens in a demo, not everything works, but this is why I'm going to make it work. So our converter didn't properly kick in within the RSocket world. But again, this is almost kind of a good thing, because while you can imagine that, hold up a second, let me just fix my dependencies. What is it complaining about? Sorry, that again. Spring message. No, message converter, okay. Nullable. MIME type. Okay, so let me just run it real quick and I'll explain to you what's going on. Okay, so so the converter, the one that we had properly registered within Spring Cloud function, didn't properly register itself within our socket. So this is like, in a typical way, if you're running it, you would report it as a bug and we would fix it. But again, since this feature is still in work in progress, we just released it as a milestone. Now I'm going to fix it. But you know, having a workaround is nice, but having a workaround that is actually part of the extension model explicitly exposed by a framework is, one may argue, it's not really a workaround. It's just it's an extension, right? So what happened is that before so what we're doing here, we compose two functions, uppercase and reverse. But as you can see from pure Java function composition standpoint, these two functions are uncomposable because they have incompatible types. This function outputs a string, this function takes a person. So what I needed to do is I needed to somehow make them compatible, right? So the function composition logic within Spring Cloud function will rely on a message converter. So it couldn't find the appropriate message converter, and that's why it kind of failed. But now all I'm doing here is registering a standard message converter within application context and provide my own implementation. It's kind of a poor man implementation that simply says and what's going to happen is that any custom converter, any converter provided by the user is going to be added at the top of the stack of the existing message converter. So your converter will take priority always over some other message converters. So in this case, I'm simply creating a person out of a string. And that's why it actually worked. So yeah, so in other words, I don't have to switch back to Stream to show you the need for this message converter. We kind of triggered the problem here as well. So I'm going to stop now and see if there are questions or what else we can talk about. Michael?
Evan?
Yeah.
We don't have any more questions at this moment.
Okay. So should we hang out for a little bit or see if people will type any questions, or you know, what else?
Oh, like, so
yes.
Related to, so this is obviously all cool within the context of functions and Spring Boot applications. I know we've got the adapters, we've talked about that. Where do you see this stuff going, you know, within the scope of FASs and those kinds of things? I know we talked about Graal a bit yesterday. Like, where do you see where do you see this kind of general ecosystem with a functional capacity going?
Well, it's almost hard to answer because quite frankly, I don't see any explicit limits, because if you, like you and I talk about the fact that I have this vision of, you know, kind of like, I feel like I plagiarized the Java message write once, run anywhere, but that's exactly where we kind of back to this world where, you know, Spring historically being in the business of saying, okay, user, you can straight in the functional requirements, we'll help you with boilerplate code. Well, it started with little libraries, templates, and stuff like that. And right now, this is where we're at, where we can provide, instead of giving you session factories, transaction managers that you have to configure, and so on and so forth, we just give you these adapters that essentially wrap your functions and expose it to different invocation models. So right now, for example, as I showed you right now, we have streaming, we have RSocket, we have several serverless platforms that are supported right now. We have REST endpoints. So we already have about 5 or 6 different ways of exposing, and there's really no limit of where the function can live, because this is your functional requirements, and then the context of its execution is going to be provided by that particular platform. In fact, earlier today, I had a discussion with a few of our engineers from a DAISY team that are interested in interested in using this as sort of a sidecar approach within that particular effort. So I mean, that's the best answer I can give you, Michael, at this point.
Cool. Do you think Graal's going to have any impact on it?
Well, I don't see why not, because now, compiling it to the, I still want to have a discussion, a more deeper discussion with a few of our guys who are in the business of dealing with Graal. But yeah, compiling a function to a native image and then running it.
So we got a flood of questions coming in now. Thank you so much to everybody participating. We really appreciate it. So will there be future support of Spring Cloud Stream for zero MQ?
I'm going to throw this question back at the person who asks. So in a nice way. So basically, you can answer the question yourself by providing implementation of ZeroMQ binder. So basically, we are a team. We do our best to serve our community. Had we had a bigger team, maybe we would add those additional binders. But for example, we do have quite a few, but we have Google binder, we have Azure binder, we have Solus binder, we have Kinesis binder. So we have, on top of the Rabbit and Kafka, we have four more binders that I know of. And out of those 4, 3 are managed by the community, right? So I would expect a zero if there is an interest, and we certainly, in fact, I'm not just saying go and implement it, we'll advertise it. No, we'll work with you, we'll help you, we'll support you, for example, personally involved with some of the guys, and we have bi-weekly meetings, so we can kind of have a better collaboration model as to how that binder should fit, and so on and so forth. So yeah, but I mean, directly, I have no plans. I have not on my priority list to do ZeroMQ, but I'm certainly not against it.
Another question is what the memory what the memory footprint for the function stack is.
5. I don't know. I mean, I don't know how to answer this question. So the memory footprint for it really depends on the implementation of your function. As a framework, we only use what's needed to be used to bootstrap your function. I mean, that's kind of the best way I can answer that.
Thank you, Oleg. Appreciate it. So is there a way to do a composition of the functions if they're not physically deployed together?
Yes. In fact, I'm actually, this question just made my day. So
yes.
Yeah. I'm actually going to demo that.
I'm just gonna throw out there. You got 11 minutes on the clock.
Oh, believe me, if I can answer this question, that will be enough. This is like one of the. I was hoping to keep this feature until Spring 1, but might as well.
So it's a sneak peek
Okay,
of
so RSocket. All right, I'm going to basically go straight to one of the test cases, and it should be simple to understand, but I'll walk you through it. There we go. Test request reply function with composition. Obviously, you saw composition through the pipe, okay? And that's functions that are collocated, run within the same JVM. But what if the function's running in different JVMs? Well, the first question you probably would need to answer is like, well, how do you even talk to that function, right? So that function has to be exposed through some type of network. So what we're doing here is we have two application contexts, as you can follow this, right? So one application context defines Spring Cloud function definition, which uppercase pipe concat, right? Another function definition defines reverse, and now I'm saying forward it to localhost port, whatever, and then after you're done with that, pipe it to rep, right? So what is actually happening here is that this becomes, well, just give you an idea about this test. This becomes the parent application context. So I'm going to send this hello to this. It's going to reverse it. Then it's going to send it over here. It's going to uppercase it. Then it's going to concatenate with itself, and then it's going to wrap it with it, like with the parentheses, which is what I'm asserting right here. So, and that's the answer to your question. So once we enable, so in other words, the trick here was what I said earlier is to be able to. It's not about just running the functions, but how can you address this function? And with RSocket, that becomes possible, and that's where we are heading. So I mean, I can run the test, but I'm sure
I think that also gets close to answering the question of where do you see RSocket evolving as an alternative to
this is not even the beginning of it. So we have another thing called RSocket broker router, which in other words, if you can see, the interesting thing about RSocket when it comes to this function is like, you can see it right here. I don't even know, I'm saying, once you invoke reverse, call this. What's behind that? I have no idea. It could be another function. It could be something. In this case, it could be, for example, like I was mentioning earlier, RSocket broker that may route to some other function, and so on and so forth. So I have no idea. This becomes to me a black box, for the lack of the better term, right? And then I just know from that after that call, I expect some type of an output, and then I'm going to do something else with that output. So now, as effectively, I'm treating call to RSocket as a call to another function. That's all it is.
Okay. And so there's a controversial question as far as is it still viable to have solutions like Spring Batch for processing large volumes of data, or moving to data streaming using Kafka, Spark, etc. with connectors will make these obsolete?
Michael?
I've made a career on doing the unsexy maintaining the unsexy frameworks and projects. For every person that asks this question, I get 5 people that say, I'm working on Spring Batch at client X, Y, and Z. The reality is that batches still exist. The batching of data still exists. It's still a very efficient way of using resources in compute, and I don't see that going away. That being said, there are new tools and opportunities to be able to explore whether or not batch is the right way of handling certain use cases. So Kafka enables you to do a lot of stuff, right? You've got the ability to process large streams of data and those kinds of things. And before you would have batched that stuff up. You don't have to now, but it doesn't mean that there are use cases where batching doesn't make sense. So yeah, I don't think batch processing is going away. Let's not kid ourselves. They've been saying it's been going away since the day computing started, and it's still here.
Just like COBOL. doesn't
Pretty
go
much. Pretty much. You can run COBOL on Kubernetes now,
away.
and as a function. So
It's probably more secure too. Are there any tuning in functions API to address a cold start, like maybe like a heartbeat function or something like that?
You can do that,
So-
but as I mentioned yesterday, we also have a functional. In fact, it's actually we have a whole section on it in documentation. Functional bean registration, specifically designed, and samples and test cases specifically designed for cold starts.
I'd also call out that the whole heartbeat concept, isn't that kind of an anti-pattern? Like, isn't the point of using functions and phases to allow them to scale to 0? And if you're not going to let them scale to 0, why are you using one in the first place? Just run it as a long-term process and use the right platform for the job.
And last question for the day. Is there support for transaction management two-phase commit in distributed composite function?
No, because first of all, well, we can have another 3-hour discussion on distributed transaction management. I can give you a short version of it. Don't use distributed transaction management. There are many other ways of dealing with the distributed transactions. But anyway, that's not in the scope of Spring Cloud Function. But remember, Spring Cloud Function is just a wrapper that decorates function with certain behavior. None of it, I mean, since we don't know the implementation, what's inside the functions, and we don't know the implementation, there's no point for us to introduce any kind of transaction management because we don't know whether you're dealing with a transactional system or not. So why would it, so in other words, it doesn't make sense in the context of Spring Cloud Function. That said, if you insist on using a distributed transaction manager, you could, of course, with other Spring frameworks, wrap these functions into proxies that will, put them under supervision of a distributed transaction manager or whatever other transaction manager you may use.
That being said, you could also use functions as components within more modern ways of handling distributed transaction aspects, like, for example, orchestrating functions via the Saga pattern, for example, and that kind of thing, where there's an orchestrator that manages those things, and functions are just components of that larger setup.
Thanks, Michael. I think our time is running out. So we appreciate all the questions. Thank you so much.
Yeah, I think we open up Pandora's box. We try to answer as many questions as we can, and then we've got to shove them all back. But I mean, the nice thing is obviously, Michael, you have your ways of being contacted. You posted those yesterday. We can send those out for ways if you have more questions for Michael, and same with Oleg. The Spring community is incredibly warm and opening and loves to answer questions. So there's certainly ways to get the answers. And of course, there's just so much information on YouTube videos and whatnot that people can follow up with other deep dives into specific things. So this was great. And I think we could always go for much, much longer, but that's just the nature of a show beast. We have to end at some point in time. So thank you, Michael. Thank you, Oleg. Really appreciate your time.
Thanks for having us.
Thank you, guys.
And just a quick reminder to everyone out there, Spring 1, so more Spring questions. Well, holy cow, we've got 2 days chock full of Spring and other things as well, like Kubernetes and microservices and platforms. And so go to spring1.io, check out the agenda. It's out now. There are 5 tracks, everything from beginning Spring to architecture to microservices to, we also have like a social track. So we have so many things for you to enjoy over the 2 days. Keynotes and bedtime stories, I think, as we joked about yesterday. And so yes, please go check out spring1.io. September 2nd and 3rd is when the event happens. Registration is online. The show is online. It's all virtual. It's all free. And then we have workshops as well. And those can all be registered on August 31st. So make sure that you check out what workshops you might want to sign up for and register as soon as possible, because those spaces are limited. And then, of course, at the end of September, we have the big show, VMworld. VMworld.com has all of the information. I think there's over 600 talk tracks. Normally there's two different VMworlds. There's one in the US and one in Europe. And this year it's all online. So we're just making it a mighty Morphin Power Ranger of, can I use that reference? Is that reference too dated to even use?
Wow.
But, a Voltron of sorts. But anyway.
Hey, Netflix has brought Voltron back. Netflix is
all right.
It's actually really good. So a little shout out
cool.
to Netflix. Yeah, they've redone Voltron, and it's actually, I've been watching it with my daughter. It's really good.
Well, as everyone knows, Netflix OSS is run on Spring, so we could definitely give shout outs to Netflix. And so yeah, we encourage you to go to
Kudos for Mighty
VMworld.com.
Morphin Power Rangers. I remember that.
Yeah, good. Okay. So anyway, it's just so much information to continue to gather and learn from. It's all happening online. If we can't meet in person, we might as well still put information out online. So that is the beauty of it, and you don't have to leave the comfort of your laptop, desktop, wherever it is that you view your computer. So that's it from us. We have a show next month. Information will be on spring1tour.io. We're going to be doing a great recap and talking about all things that happen at Spring One. We're going to have some really great Spring minds on that. And so, yeah, we're here to talk Spring and make sure everyone continues to get stronger in it and leverage it for your work. So thank you again, everyone. And Yvonne, Jamie, Paul, Newt, everybody on the production side, great job. Michael, Oleg, take care of yourselves. Be safe, everyone.
Thanks.
Cheers.